Student, today we will learn the chapter logarithmic series. Student, before going to this topic, you should be understand the chapter binomial theorem, then exponential series, and then you should be learn this topic, logarithmic series. Okay, student. So I'm going to start it. As you have already learned in the chapter exponential series, that is a to the power, it is y, equal to 1 plus y log at e base a. It is exponential base and y is this, and a is constant, upon factorial 1 plus y square log ea square upon factorial 2, and similarly so on. Okay, student, this series we have already find in exponential chapter, so if you want to be known in detail, go through that chapter, okay, as I already given in the previous video. Now let a equal to 1 plus x and x less than 1, then we can understand 1 plus x to the power y is 1 plus 1 plus x log ea upon factorial 1 plus 1 plus x square log e base square upon factorial 2, and so on. Now student, these are two parts. In LHS, using binomial theorem, as already explained in the binomial theorem, if x is less than 1, we can write this in this way: 1 plus n x, n is y, plus n minus 1 or y minus 1 upon factorial 2 x square plus dash dash dash. Now we will compare of this series and this series, here and here. What we have to going to compare? That we have to going to compare the coefficient of y. Here the coefficient of y is x, and when we open this, coefficient of y is minus y here, that is minus x square upon factorial 2. Okay, here is y square and minus y. I am asking you about minus y. So coefficient of minus y is minus x square upon factorial 2. And here the coefficient of y is you can understand that is log EA. Okay, so log EA is, we can write x minus x square upon factorial 2 plus x cube upon factorial 3, and so on. Okay, so we can say when we comparing equation 1 and 2 with the coefficient of y, here is log EA and here is y minus y x square upon factorial 2. Or y we can write 1 plus x. Okay, So now from equation 1 and 2 we can say coefficient of y, that is log e1 plus x, is equal to x minus x square upon 2 plus x cube upon 3 minus x4 upon 4 plus and so on. Let us see again. Okay, the coefficient of y is log ea, log e1 plus x here, and here is x. Okay, now open this here. What we got it? Minus 1 x square upon 2 into 1 2, and similarly in the next you will find 3. You can check yourself. Okay, so we get it log e1 plus x, x minus x square upon 2 plus x cube upon 3 minus x square 4 upon 4 plus and so on. This is a series of log e base 1 plus x. Okay, this you have to learn it. That is known as the logarithmic series. Okay, student. Now, the second point I want to be say, if put x as minus x, then we will find log e1 minus x, okay, minus x minus x square upon 2 minus plus minus x cube upon 3 minus x4 upon 4. Then you can see the all terms are negative. Isn't it? This is positive, power 4 negative, cube negative, then it is negative. So all terms are in negative. Now if we add this equation and this equation, what we get it? X minus x will be cancelled, this will be add. Okay, if we subtract, then this will be add and this will be add, right? So let us subtract it. Now 1 minus 2, what we get here? Log e1 plus x minus log e base 1 minus x. We get twice of x plus x cube upon 3 plus x to the power 5 upon 5 plus x to the power 7 upon 7 and so on. Okay, student. So log m minus log n, we can write it log m upon n. So we can write this way. Okay, student. So now this phenomena also you have to learn it. This is also very important point. This you have to learn it. Okay, student. Now you can see in equation log e1 plus x equal to x minus x square by 2 plus x cube by 3 minus x4 upon 4. If we put x equal to 1, so we get at e base 1 plus 1 value of log 2. Then we will get 1 plus 1 square upon 2 plus 1 cube upon 3 plus minus 1 4 upon 4 and so on. So what we got, the value of log 2. Log e base 2 is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus dash dash dash. This you have to learn it. Okay student. Now again, if we taking it right this way, adding only 2 terms at a times, so we get now log e base 2 equal to, taking LCM here, we get 2 minus 1 into 2 plus 4 minus 3 into 4 plus 6 minus 5 and so on. We get log e base 2 equal to 1 upon 1 2 plus 1 upon 3 4 plus 1 upon we got here 5 6, so that it is in learning it is suitable. So this also you have to write. Okay student. Now again check. Now I am telling you to leave the first term, then add this, but you got it. Now again log 2 equal to 1 minus, taking 1 by 2 minus 1 by 3 minus 1 by 4 minus 1 by 5 minus and so on. Now taking LCM here, what we get it? 1 minus, we take the LCM 2 3 minus 2 minus, take the LCM 4 5 minus 4, taking LCM 6 7 minus 6. So what we get? Log e base 2 equal to 1 minus 1 upon 2 3 minus, it is multiplied, okay, 1 upon 4 5 minus 1 upon 6 7. So this you have to learn it. Okay student. Now very important point is this, if we write this as let it is equation 1 and equation 2. If we add 1 and 2, what we get it? Log e base 2 plus log e base 2 left side, and right side, if we taking this one separately and taking the LCM from here, what we get it? Plus 1 1 2 minus 2 3. Similarly the next term you can see here also, this we have it and 1 3 4. So we write 1 3 4 minus 1 upon 4 5, and same way you can add more term. Now you get 2 log e base 2 equal to 1 plus, now taking LCM 1 2 3, we got 3 minus 1, and here also we can take LCM 3 4 5 minus 3. So this way we can find a new series for 2 log e base 2, that is 1 plus 2 upon 1, 2, 3 plus 2 upon 3, 4, 5 plus 2 upon 5, 6, 7 and so on. This you have to learn also. Okay, now student, if we add equation 3 plus equation 1, what we get is 2 log 2 plus log 2, we get this 1 plus 2 upon let we add 2 into equation 1 and then add equation 2. What we get here, equation 2, 1 minus 1, 2, 3, and we multiplied here in equation 1. In equation multiplied by 2, 2 upon 1, 2, 2 upon 3, 4. Okay, this way. So what we get here? We get here 1 plus 2 upon 1, 2 multiplied in equation 1 by 2 and adding the equation 2, we get LCM 2, 3 plus 2 upon 3, 4 minus 1 upon 4, 5 plus 2 upon 5, 6 minus 1 upon 6, 7 plus and so on. So we get 3 log a base 2 equal to 1 plus, taking LCM here, we take the LCM 1, 2, 3 and we get here 6 minus 1 plus, we take the LCM 3, 4, 5, 10 minus 3 and then we get LCM 5, 6, 7, 14 minus 5, okay, and so on. So we get the next equation is 3 log e base 2 equal to 1 plus 5 upon 1, 2, 3 plus 7 upon 3, 4, 5 plus 9 upon 5, 6, 7 and so on. This equation also we have to learn it. Okay. Now if equation 2 multiplied by 2 and adding equation 1, then what we get? We get again here 3 log 2 equal to 2 plus this. All what I am telling you, this is your basic formula and it can be asked you according in the question. Okay, so if you learn this very well, then you can solve so many question easy way. So we understand how we are doing this. So now here we can take the LCM 1, 2, 3, then we get it 3 minus 2, again we have take the LCM 3, 4, 5, then LCM is 5 minus 2, 3, 4, 5 and 3 minus 2, we are taking the LCM 1, 2, 3, 3 minus 2, okay, we are taking LCM 3, 4, 5. So 5 minus 6. We write here 6. Now similarly, if we are taking the LCM 5, 6, 7, we got 7 minus 10. Okay, so what is the left here? 3 log 2 equal to 2 plus 1 upon 1, 2, 3, and it is minus 1 upon 3, 4, 5, and it is also again minus 3 upon 5, 6, 7, and so on. So this you have to learn it. Okay student, so using these all what I am describing here is depend on equation 1 and equation 2. How we have used this equation 1 and equation 2, this I have explained here. So when we add 2 equation multiplied by 2 and adding, then we have got it this. These are the long questions, and if you know the digit of this and you recognize plus minus, what is the value of here, what is the value of here, so you can find out easily. Okay student, now I am going to the next point. If we want to find out the value of any digit in log, so we use the log table. I am not going to describe you the table. I am going you that how this table is made of value, how you can find the value, okay, for this table, how you can find the value of log 2 at e base, and how you can find the value of log 3 at e base, and so on. So I am going to you construction of log table. Okay, so now you can see we have already described the series in the previous board, that is log e base 1 plus x upon 1 minus x. What we got it? That we got it 2x plus x cube upon 3 plus x5 upon 5 plus and so on. Now if let put at x equal to 1 upon 2n plus 1, so what we get? We get here 1 plus x upon 1 minus x as 1 plus 1 upon 2n plus 1 upon 2n plus 1. Taking LCM here, 2n plus 1, we got this, and taking LCM here, we get, now what we left here, 2n plus 2 upon 2n, and this LCM is cancelled out, and taking 2 common, n plus 1 upon 2n, again 2 is cancelled, we got n plus 1 upon n. Okay, so now we will put this value here and this value here. So what we get here, that is log n plus 1 upon n is equal to 1 upon 2n plus 1 plus 1 upon 3, 1 upon 2n plus 1 square, 2n plus 1 cube, plus 1 upon 5, 2n plus 1 to the power 5, Okay, so if we want to be put here, you can see let n equal to 1. So what we get it 1 plus 1 upon 1 right side log 2. Okay, so we got the value of log 2 at e base. So what is the value of log 2 at e base? 1 upon 1 into 2 plus 1, that is 3, 1 upon 3, 1 upon 3 cube plus 1 upon 5, 3 to the power 5, and so on. Okay, student. So now we have to calculate it. So how we will calculate it? We can see here we calculate first 1 by 3, 1 by 3 cube and 1 by 3 to the power 5. This we have to calculate it. So if we divide 1 by 3 and then the value of this divided by 9, we can calculate 3 cube, and again if we divide the value of again 3 square, and this way you can find the value regularly. So calculating after this value, we can find out this easily way calculation. Okay, and then multiplied by 2, we can find the value of log 2, right? So listen again. First we find the value of 1 by 3 and divide by 9, then you can find the value of 1 by 3 cube. Okay, again divide by it by 3, then you can find the value of 3 to the power 5, and so on. This way when you calculated it easily way, then you can find the value of, and multiplied by 2, you can find the value of log 2, right? So after getting this, we can find out the value of log 2 is 2 multiplied by, when we solve these equations, we can get the value of 0.346573 dash, and multiplied by 2, we get the value of log e base 2. It is on e base. This you have to remember very well. That is, we get 0.693147, and so on. This you have to learn it. It is a very important value, and that will be help you to do so many questions, right? It is but at the base of 2. Okay, student. So in this value I am putting the value of 1. So we got the value of log 2. Okay. Now if n equal to 2, so what we get? We get here log 3 upon 2 log 3 minus log 2, and we know the value of log 2. Then subtracting this, we can find the value of easily way of log 3. Okay, now after when we got log 3, we will using this, we can find the value of log 9. After getting of the log 9, we can find the value of if n equal to 9. So we can find the value of log 10. Now when we know the value of log 9, put the value of here, so we can find the value of log 10. Okay, after getting the e base or log e base 10, we got it log e base 10, that you have to learn it. At log e base 10, when we calculate it, so we will get it 2.302585. So this digit up to after decimal of 6 digit, if you learn it, so it is will be beneficial for you. Okay, now student, we know that if this formula log a base b equal to, if we want to change it, a base e into e base b, so we can write it this way, log if we want to know the value of log e base changed at log 10 base, we can use this formula. Okay, so if we want to know the value of log 10 base of any value, log 10 base n, if we want to change is 10 base e into log e base n. If we know the value of log e base, then multiplied by this, we can get the value, okay, of log 10 base. So we can also write this at e base 10. Okay, and now just we have the find this value 2.302585 log e base n, and we divide it, so we get this value 0.434294 into log e base n. So value of log e base n we multiplied by this, we get the value of log 10 base. So what we got the formula log 10 base n, so we use this value 0.424294 and multiplied by log e base n. Now if we remember this formula, we can find the value of log e base to log 10 base. In the table, all the value of log 10 base is given, and how that value is given. First we find that before given formula at log e base n, then using this calculation we fill up that table. Okay student, so I think you understand the log table. Before upgrading the questions, I will be simply explain some log formula as you know well, but I am explaining here. Okay, a to the power n equal to m, we can write in this exponential form in this way. Okay, this is the basic formula. You know well, but I am telling you. Okay, if at the same base the product is given, we can write at the same base as the sum of this. If it is division form, then we can write in this form. Okay, so this formula you have to know very well, but just before the questions, I am telling you again. You can write it. Okay, and also if you want to be want to change the base, you can write this way: a to the power b into log b to the power c into log c to the power a, then it is equal to 1 as a product. You can also see here. Now if we writing this way, log b to the power c equal to 1 upon log a to the power b into log c to the power a. So we can rewrite this here. Log b base a upon log c base a. Okay, this way also can you write here. This want to be here. If you want to be taken here, so you can write a base c and a base b. So this way you can use all this formula as you can want to be know solve the questions. Okay, now what we have learned today in the logarithmic series, we will go to the some questions. Okay, so student, now solve these two questions. Prove that log m upon n is twice of m minus n upon m plus n plus 1 by 3 m minus n upon m plus n whole square whole cube plus 1 by 5 m minus n upon m plus n whole 5. Now student, if you go through these questions to understand this better, 2x plus x cube upon 3 plus e to the power 5 upon 5. So we can say this value is, using formula, log e base 1 plus x upon 1 minus x, 2 x plus x cube upon 3 plus x to the power 5 upon 5. We can see here x equal to m minus n upon m plus n. So we can get the value of this by putting this value. Okay student, so calculating this you can solve easy way. Now I think you are understanding. This LCM will be cancelled here. What we get here, 2m upon this will be 2n. Okay, so we get the value is this, that 2m upon 2n or m upon n. So we can put here add m upon n. So we can say LHS equal to RHS, hence proved. Okay student, so and this is a very suitable questions to find the values of log table. Okay, now we are going to one more questions, that is at log e base 1 plus x square and find expansion of this. So we can see here, if we multiplied here 1 minus x here and divide by 1 minus x, so we get here a cube minus b cube factor a minus b, a square plus ab plus b square. Okay, so student, we can write here 1 minus x cube upon 1 minus x. Again, in short, we can write here log e base 1 minus x cube minus log e 1 minus x. Now, using the series of log e 1 minus x, putting the value of x cube, we get x cube minus x cube whole square upon 2 plus x cube whole cube upon 3 minus x cube whole 4 upon 4 and so on. And again, we subtracting it, putting this value x minus x square by 2 plus x cube by 3 minus x4 by 4 plus x5 by 5 minus x to the power 6 upon 6 plus x to the power 7 upon 7 and so on. Now, if we write it in the power of ascending form, what we get here? We get here minus, and this is the series of is a minus, so all terms are in negative. Since this is the minus, so all the terms are negative. Okay, so now we can see minus minus plus x. So we get here x. Now square here is a cube, so we write the first plus x square by 2. And again we can see it descending is x cube and x cube, so plus 1 by 3 and minus 1 by 3. Okay, so we get here minus 1 and here plus 1 by 3. So we get here in bracket we can write here 1 by 3 minus 1 x cube, right? Now we can take the x to the power 4. Here is the power 6, so we can write only plus x to the power 4 upon 4. Okay, now x to the power 5, it is x to the power 6, so we can write minus x to the power upon 5, and so power 6 and 6, power 7 and 7, we can go through this way in ascending form. Okay, so write it. Now we get x plus x square by 2, this will be minus 2 by 3 x cube plus x4 upon 4 minus x5 upon 5 and plus and so on, and this will be your answer in ascending form. You can write more step if you want to be. Okay, so student, I will try to solve one more questions. Let if alpha and beta are the roots of the equations x square minus px plus q equal to 0, then prove that at log e base 1 plus px plus qx square is equal to alpha plus beta x minus alpha square plus beta square upon 2 x square plus alpha cube plus beta cube upon 3 x cube minus and so on. So you can say, since alpha and beta are the roots of quadratic equation x square plus px plus q equal to 0. So if you don't know what is the quadratic equation and what is the relation of the roots with the coefficient of x square and x, you should go through this chapter, the quadratic equations. Okay, I have already explained. Okay, so you can write here sum of the root is minus b upon a, value of b is 1, a is 1, that is minus b, and product of the root is c upon a, q upon 1. So we can write it q upon 1, it is equal to q. Okay. Now in the equations, if we write the value of p and q is here, we will got it. What we got it? We got it p is minus alpha plus beta and q is alpha beta. So we can calculate it 1 minus alpha x minus beta x plus alpha beta x square. Taking the factor, we can get 2 factor 1 minus alpha x and 1 minus beta x. Okay student, so now putting in LHS, hence LHS equal to log e 1 minus alpha x 1 minus beta x. We can use the formula as I already told, log mn equal to log m plus log n. Okay, now using the expansion of this is negative, so all the terms are in negative. Let's check it before what I have given the questions. Minus px, so alpha plus beta x is p, alpha beta is q, and here the question is given px plus qx square, p what I have written here, is minus, so we write here minus, so that is equal to p. Okay, so we write here alpha plus beta x, so we got it in plus, all are in plus. Okay student, okay, now it's okay. So we are getting here plus plus. Now using the formula of expansion, we can write x plus x square upon minus 2 plus x cube upon 3 minus x4 upon 4 and plus dash 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 in second bracket we can write it beta x minus beta square x square upon 2 plus beta cube minus, and so now adding this we can get it alpha plus beta x, and taking minus common, x square by 2 common, so we get alpha plus beta square upon 2x square, plus similarly what we get here, alpha cube plus beta cube upon 3x cube, okay, and so on. So hence we have proved the LHS equal to RHS. So student, you can solve so many questions according to this what I have explained you. So learn it more and do practice, and if you go through the questions from your book, you can be able to solve so many questions. Thank you for watching. Thank you.